Hi dear, we'll start the next chapter in the physics, that is electricity. Okay, chapter number 12, electricity. Okay, so we have seen many forms of energy, right? Energy means what? To do work, right? There are so many forms of energy, that is mechanical energy, kinetic energy, light energy, chemical energy. So many energies we have seen, right? So energy can neither be created nor be destroyed. It can transfer from one form to another form or from one substance to another, right? So that electricity is also a kind of energy. Okay, it is a form of energy. Okay, but it is very controllable and convenient form of energy, right? So whatever thing is connected to electricity, we are able to use it very easily, right? We can control that by just pressing the start button. We can able to get the things, right? We will done, the work has been done, right? So it is a controllable and convenient form of energy for variety of uses in homes, schools, hospital, etc., industries, etc. Okay, so what does this electricity mean? So what does this electricity constitute? For example, if a water is flowing, means flowing per time, per unit time, means we will say this is a water current. Okay, if air is flowing, means we will say that air current or wind current or wind, right? Likewise, what is electric current? Electric current means it is a flow of charges. Flow of charges. What is this charge? Charge means what? Charge means you would have seen, if you rub your hand, if you are having more hairs in your hand, if you look into your father's hand, if you rub your father hand with a comb, you can see some of the hairs are attracted towards the comb. Do you ever found see this one? All the hairs will be attracted towards the comb. What happens actually? Okay, so you know that everything is made up of a single smallest element, right? Atom, right? All the atoms are neutral in nature. Okay, neutral in nature, it will not attract. If your hand is there and your comb is here, means it will not attract. Okay, because both are neutral. It is not charged particles, right? It is not charged. So both are neutral. When you rub over here, some of the electrons from here will move to this comb, and some of the so if electrons are moving means here it becomes positive, and here the comb got negative charge, more negative electrons will be more here. Since electrons are moved, here it becomes positive. So here it acts as a negative, and here it acts as a positive thing, so it will attract each other. Okay, it will attract each other. Some force is causing, that force is called your that what causes this force between these two hand and the comb? That is flow of charges, and is flow of electrons. Okay, so what is mean by electric current? The flow of charges. The flow of charges in a conductor constitute the electric current. For example, if this is a wire, metallic wire, it contains more electrons. If the electrons start moving, that means a current is there, right? Okay, uh, which causes the flow of electron? Some attraction, that force, right? That's flow of charge in a this, that we will study in detail. Okay, that now we'll see what is current. Electric current, the flow of charges. If the particles start moving, electrons start moving, then we can say there is a current. Okay, electric current. What current? Electric current. Electric current is nothing but the flow of charges. Okay, we can say it in another way, the amount of charge flowing through a particular area in unit time. Unit time means per second. Okay, per 1 second. Okay, the amount of charges, how much charge is flowing through a particular area in unit time is called electric current. Or we can say it in another word, what it is, the rate of flow of electric charges. Rate of flow of electric charges. Okay, so how will you denote this electric current? It is denoted by, electric current is denoted by I. Okay, electric current is denoted by I, and the charge we are telling, no, the flow of charge is flow of charges. The charge is denoted by Q. It is denoted by Q, and the time, how much amount of charge flowing through a particular area in unit time. So time also we are considered, right? So it is time is denoted by T. Okay, so we have seen that what is electric current, amount of charge flowing through a particular area in unit time, right? So electric current I is equals to charge, flow of charge per unit time. Okay, how much charges flows in a particular area per second. Okay, so charge per time, charge is denoted by Q and time is denoted by T. Okay, so I equals to Q by T. I is electric current, Q is a charge, and T is the time. Okay, so this electric current is given by if a net charge Q flows across any cross section of a conductor in time T. Okay, that is your electric current. Okay, so what is the unit? Every time if you are, for example, if you are written 153 height means what is this 153 meter or centimeter or millimeter. First you have to denote with the unit, right? So your height may be 153 centimeter. Okay, if you wrongly mention 153 meter means that's totally wrong, right? So you have to mention with the unit. Your height is 153 centimeter. Likewise the electric current is also having a unit. Okay, what is the SI unit of electric current? It is ampere. Okay, the SI unit of electric current is ampere, and this ampere is denoted by A. Okay, so this is the standard unit, and we are having a smaller units also. Smaller units of electric current are milliampere. 1 milliampere equals to how much? 10 to the power of minus 3 ampere. Or we can say it in this way also. 1 ampere equals to 10 to the power of 3 milliampere. Okay, 1 ampere contain 10 to the power of 3 milliamperes. Okay, or 1 milliampere equals to 10 to the power of minus 3 ampere. Likewise you are having a microampere also. Micro means always 10 to the power of 6 minus 6. 1 microampere equals to 10 to the power of minus 6 ampere, or 1 ampere can be written as 10 to the power of 6 microampere. Okay, these are the smaller units of electric current, and your standard unit is ampere. Okay, what is that 1 ampere means? What is that 1 ampere? 1 ampere means when 1 coulomb of charge. What is that? 1 coulomb of charge, always known as current means charge flows per second. Okay, how much charge has to pass? 1 coulomb of charge flows through a conductor in 1 second. Okay, through a conductor. For example, this is a wire at a particular point in 1 second. 1 second, if 1 coulomb of charge pass means, then it is called 1 ampere. Okay, when 1 coulomb of charge flows through a conductor in 1 second, then the current passing through the conductor is 1 ampere. How much current is passing through that conductor? 1 ampere of current. 1 ampere of current. Okay, 1 ampere. So 1 ampere can be written as 1 ampere equals to 1 coulomb per second. Per second means per 1 second. Okay, 1 C by 1 S. Okay, what is that coulomb means? What is that coulomb? We said that when 1 coulomb of charge, we said, what is the charge? What is this coulomb? Coulomb is nothing but the SI unit of electric charge. Unit of electric charge. Okay, what is the unit of electric charge? Charge is also will have some unit, right? For example, like weight, for weight, mass, weight, for weight, and we are marking with the unit, right? Gram, kilogram, like that. So we have charge, electric charge also have unit, SI unit called coulomb. Okay, coulomb. Okay, so they said 1 coulomb of charge. 1 coulomb of charge means how much it will be, right? You know that flow of electrons is called electric current, right? So flow of electrons. You know that what does this? Only this positive and negative will attract each other, right? So the protons have positive charges and electrons have negative charges. How much charge it contains, right? The flow of charges is called electric current. We said how much charge it contains. 1 electrons contains how much charge? it is all that we have seen in the 9th standard itself. In chemistry we would have calculated, right? One electron, this one electron possess how much charge? 1.6 into 10 to the power of minus 19 coulomb. Very less charge. Okay, it contains only less charge. 10 to the power of minus 19 means what? How many zeros? 0.00000016 it would have. It would have that much charge. We have written like this: 1.6 into 10 to the power of minus 19 coulomb. Okay, one electron possesses only this much very small amount of coulomb. But what we have seen, 1 ampere means 1 coulomb. That means 1 coulomb of, if you want 1 coulomb of charge, means how many electron has to pass? This electron has only 0.0000 up to 19 zeros, right? 19 zeros. Very small charge. To get 1 coulomb, how much electron has to pass through that? That we need to calculate, right? 1 electron equals to 1.6 into 10 to the power of minus 19 coulomb means 1 coulomb equals to what? If you want to calculate 1 coulomb, this will, since it is multiplication, it comes down, right? Division, right? 1 by 1.6 into 10 to the power of minus 19 electron has to pass, right? That is equals to 1 coulomb. So we cannot divide this. So to remove this decimal point, I multiplied both numerator and denominator by 10. So it becomes 10 by 16 into 10 to the power of minus 19. When this 10 to the power of minus 19 goes up, it becomes 10 to the power of 19 plus 19. So 10 divided by 16. 10 divided by 16 comes out to 0.625. Okay. So 0.625 into 10 to the power of 19 electrons charge. Okay. 1 electron possesses only 1.6 into 10 to the power of minus 19 electron charge, coulomb. So to get 1 coulomb means how much charge? Charge of 0.625 into 10 to the power of 19 electrons. That much electron has to pass. See, into 10 to the power of 19. So if you want to write numerically means, you'll not be able to understand 0.625 means what. So if you able to write like this, 6.25 into 10 to the power of 18 means 6 into 10 to the power of 18. That many electrons charge is equals to 1 coulomb. Approximately we can write, since I move this point from here to here, so it becomes 10 to the power of 18. Okay, need to multiply by move this point, it becomes 10 to the power of 18. So we can approximately write 1 coulomb equals to 6 into, instead of 6.25 you can write 6 into 10 to the power of 18 electrons charge. The charge possessed by 6 into 10 to the power of 18 electrons. That much electrons has to combine to get the charge of 1 coulomb. Because one electron contains only 1.6 into 10 to the power of minus 19 coulomb. So so how many electrons constitute a 1 coulomb means 6 into, in the book they are given 6 into 10 to the power of 18. So you can use this value instead of 6.25. Okay, 1 coulomb equals to 6 into 10 to the power of 18 electrons charge. Okay, these many electrons combine to give the charge of this 1 coulomb. Okay, so 1 coulomb equals to 6 into 10 to the power of 18 electrons charge. Okay, it is the charge of 6 into 10 to the power of 18 electrons. Okay, so we'll see some numericals. A current of 0.5 ampere is drawn by a filament of an electric bulb for 10 minutes. Okay, find the amount of electric charge that flows through the circuit. How much electric charge will flow through that? What is given? Current I is given 0.5 ampere. Time is given as 10 minutes. Okay, so we are not supposed to substitute in minutes. We are supposed to convert this into seconds, right? Per second only we have calculated the electric current. So 10 minutes equals to 10 into 60 seconds. Okay, so 600 seconds. What we are supposed to find? We have to find the charge Q. Okay, so we know that the current equals to charge by time, right? We need to calculate only charge, right? So keep the charge here, bring the T to this, transpose to this side. Since it is in division, it becomes multiplication, right? And transpose to the next side. Okay, therefore Q equals to I into T. I into T. What is the value of I? 0.5 ampere. Ampere means what? 1 ampere equals to 1 coulomb flows per second, 1 second. Okay, so C by S, right? Instead of writing A, you can write it as C by S. Time is 600 seconds. The seconds get cancelled. So 0.5 into 600 will give 300 coulomb. Charge equals to 300 coulombs. Okay. Next question. If 20 coulomb of charge pass a point in a circuit in 1 second, in a particular area, how much charge is passing? 20 coulombs of charge. 20 coulombs of charge is passing. What current is flowing in that circuit? Okay, so charge they are given 20 second, time 1 second, sorry 20 coulomb, time in 1 second. No need to convert anything. Okay, it's already given in coulomb and seconds, and we need to find the current. I equals to question mark. You know that I equals to Q by T. Q is given as 20 coulombs, time is 1 second, so 20 by 1 equals to 20. C by S means what? Charge per second means what? Ampere. So current I equals to 20 amperes. Okay. Next. A current of 4 ampere flows around a circuit for 10 seconds. Okay. For 10 seconds, a 4 ampere current is flowing. How much charge flows past a point in the circuit in this time? So through the circuit at a particular point, what is the charge flowing? Okay, we need to calculate the charge. Current is given as in ampere itself, time given in second. We need to find the charge. So directly we can substitute I equals to QT. We need Q only, so keep the Q here, bring the transpose this T to this side, so it becomes I into T. Okay. I is 4 ampere and T is 10 seconds. So ampere is written as coulombs per second. So seconds get cancels, and 4 into 10, 40 coulomb. Charge equals to 40 coulomb. Okay. So 40 coulombs of charges, 40 coulomb of charges flowing through a particular point. Okay, at that point. Next, what is the current in a circuit if the charge passing through each point is 20 coulombs in 40 seconds? We need to calculate what is the current. Okay, we need to calculate the current. If the charge passing through each point is how much charge is passing? 20 coulomb of charge. 20 coulombs, and in what time? Time 40 seconds, for 40 seconds. Okay, so I equals to Q by T, where Q is 20 coulombs and T is 40 seconds. 0 get cancelled, 2 and 4, 2 times, so it becomes 1 by 2. C by S means what? Ampere. 1 ampere equals to 1 C by 1 S, right? So C by S means ampere. So 1 by 2 means what? 0.5. So current equals to I equals to 0.5 amperes. Okay. Thank you.